Okay, I was asked to do number 5 from the homework from the textbook on optimizing this rectangle between two curves. So that's what I'm going to do. Sad looking picture, I know, but hey, I'm not an artist, okay? And what I do know is that this curve that opens up is this function 1/4 x to the 4th minus 1, and the one that opens down is 4 minus x squared. And what we're told to find, we want the largest width, or let me just see what the question said again. Yeah, not the largest width. We want the largest area, so we need the width that produces the largest area. And since we're talking about area, we know that the area of a rectangle is length times width. So this is the formula I need to fill in. Now, just like the last video, remember this y-axis produces symmetry. So this distance is x and this distance is x. So this whole length here is 2x. So area is 2x times the height, right? And the height function's the one I've got to find here. So it's very simple. What you're going to do is you're going to take the top curve, meaning, you know, the curve that touches the upper vertex of the rectangle, which is 4 minus x squared. So it's top curve minus the bottom curve. That's usually how kids remember it. But I got to remember to use parentheses because I have a couple of terms here. The bottom curve, or the curve that touches the bottom vertex, is this 1/4 x to the 4th minus 1. And I'm going to clean that up. So 4 minus x squared minus 1/4 x to the 4th plus 1 is what we get, right? Now, this is not the area function. This is just this whole distance here, top curve minus bottom curve. So this is representing our width, the width of our rectangle. So our area function is the length, 2x, times this thing. I'm going to clean it up. I'm going to write it in descending order. So negative 1/4 x to the 4th minus x squared plus 5. Okay? So this right here is the big deal. And down here I'm going to clean that up a little bit more. So area is equal to negative 1/2 x to the 5th minus 2x cubed plus 10x. So just by distributing this 2x to each term here, you know, a 2 is going to cancel out, so I'm left with negative 1/2 x to the 5th. Here I'm going to have negative 2x cubed, and of course 10x. Okay, so this is the area function. Now, you know, at this point here, I could just graph this thing. X to the 5th. So I'm putting this in my calculator, so bear with me a second. Minus 2x cubed plus 10x. Right? I can put this into my calculator and I can hit the graph key. And I can do second calc maximum, right? Little to the left, enter, little to the right, enter, and enter one more time. And so what I get is 1.064. Now, what is that? Well, that's the critical number if I were to take the derivative of this thing. So if I take the derivative of this, I set it equal to 0 and I solve for x, that's what I'm going to get. This is the critical number from the graph of the derivative. So remember, we have two endpoints, right? 0 and what else? We don't know, but we're going to find it. And this needs to be somewhere in between, right? It cannot go outside of our interval. So we need to find our domain. And again, it's going to be 0. And the easiest way to find the domain is to graph the two curves and figure out where they intersect. So I'm going to do that. Let me put this here. Okay, so 0.25 x to the 4th minus 1 is the bottom curve, or one of the curves, and then 4 minus x squared is the other curve, and you hit graph. And so there's the two functions, okay? And remember, we're going to go from 0 to positive infinity to get our interval. I'm not going to go from negative. You could go from negative this to negative that, but it's easier just to go from 0 to some point to the right because, again, symmetry, right? This y-axis produces symmetry on both sides. So anyway, if I just do second calc intersect, and you know, I want this intersection point, so I get a little bit close to it, tell it the other curve, and then guess it's going to give me 1.703. So that is going to be our domain. Okay, that's our domain. Now the thing is we've got to test this and that and that in there. Well, look, if I plug this into this function, I'm going to get a 0 area. If I plug 0 in, I'm going to get a 0 area. Okay, or you know, if I plug this in, I'm going to get really close to 0. It might as well be 0. So it's generally always going to be the number in between. So, okay, well, that's the value that I need right here. And so at this point here, once again, you know, if I go back to that other function, and I didn't write it down, go figure. But if I go back and I graph my area function, sorry, I'm not being very efficient tonight. Okay, so there's the area function, not the derivative, right? Again, if I do a second calc maximum, a little to the left, a little to the right, and enter, right, we get that 1.064 as the x-axis, and the height is going to be 7.549. Okay? That's all you need to do. That's it. So I hope that helped. If not, let me know, because I was a little scattered on this. It's just been one of those days. I'm going stir crazy at home. My legs hurt, and my husband loaded the dishwasher upside down. So anyway, bless his little soul, he tries. But anyway, let me know if there are any more questions with this, and I'll be more than happy to try and clarify it. Have a good night.